Hello, guys. Welcome back to MathZone African Motives. We are still on our engineering science and two, and this is HIT from the question paper of November 2023 exam. Question 7.1. We are given to name the instrument used to measure body temperature. Which instrument do you use to measure your own body temperature? What do you use? There we know that we're gonna use what? A thermometer, all right? Isn't it? There we're gonna use what? A thermometer. All right, 7.2, name 3 factors that will influence the change in length. Take note, the change in what? In length of the metal. All right. Given a certain metal, we know that the change in length, if you've forgotten this, you go back to your formula sheet where you are given the formula for the change in length. There you can have your answers, guys. Everything is given here. This is the change in length. And we understand, this one here, the change in length is equal to what? The original length times what? The linear coefficient of expansion. There's an expansion there that is going to happen. And what? The change in temperature. These are the 3 factors that affect the change in length. So you use the formula to answer this type of a question, all right? If you know your formula, then you just take from what? From your formula. Even they can ask, if you remember on electricity, there's that question that they ask 3 factors that affect the resistance of a certain metal or material. You take from the formula of the resistance, all right? So that means in this case, from our formula for the change in length, which states that we've got the original length times the linear coefficient of expansion times the change in temperature. It means what is going to affect this change in length that is happening is one, the original length. We're going to need the original length of the metal. So that is the first thing. We're gonna need the original length in what? In meters of the metal. All right, what else do we need? We are going to need the linear coefficient of what? Expansion. So we are going to need the linear coefficient. So that's coefficient of expansion there, of expansion, okay? What else? The change in temperature. So you're gonna need the change in what? In temperature. And this must be in degrees Celsius, since our linear coefficient of expansion is affected per degree Celsius, all right? It's whatever value that you're gonna have, but it's per degree Celsius, whatever that you have per degree Celsius. So that means our change in temperature must be in degrees Celsius, not in Kelvins, all right? So that's it. These are the 3 factors that they just needed them. 7.3, we are given, okay, let's try to be together here. So 7.3, we are given that calculate the mass of what? The mass of coal. So we've got the coal in this case, all right? We've got the coal and we need its mass, all right? For coal, we need the mass of what? The mass of coal. What is gonna be the mass of coal? To heat 500 liters of, take note, what are you heating there? All right, take note of what you are heating. What are we heating here? We are heating 500 liters of water. So meaning, to remember, in terms of water, it follows that whenever we are dealing with water, a kg, a kilogram of water is equal to 1 liter for water. All right. So that means the 5,000 liters of water that we are given is the mass that we have there. So we have got the mass of water, which is 500, the 500 liters there. So it's going to be 500 kilograms. From, it is heated from where? 8 degrees Celsius to 90. That is from the initial temperature T1 of 8 degrees Celsius to the final temperature T2, which is 90 degrees Celsius, our T2, which is the final 2, up to that temperature of 90 degrees Celsius. If there is no heat lost, take note, they are saying the heat is not lost there. So meaning to say, if the heat is not lost, what does it mean? It means the heat that is being used by the coal to heat the water is going to be equivalent to the heat of the water that we are having at the end, because we are heating the water. So at the end, they'll be equivalent. Okay, because no heat is lost. We are taking as if heat is not lost, of which is not 100% efficient, as we know that it can change. All right. So the question was, calculate the mass of what? Of copper. How can we calculate the mass of copper from this? We need M from the copper. All right. What we understand or what we know from this consideration, because these two can only be related by this. All right. The heat from the coal. How do you obtain the heat from the coal? All right. The heat from the coal, we simply obtain it from the product of the mass. The heat from the coal is simply the mass of coal times the heat value. Will be given the heat value of what? Of your coal, of the coal. From your information sheet, we have this information given. All right, let me take you to the formulas, because it might be. Then for water, let me just write mass times the specific heat capacity times the change in temperature. So like I said, let me just take you around the formula so that you see what I'm trying to say, like what am I trying to have here. So these are the formulas. If you check here, there are formulas for Q here. This one is when you're dealing with liquids, all right, where there's specific heat capacity. We can be dealing with oil, we can be dealing with water, with a specific heat capacity. We can even I mean, where we are obtaining this. Okay, it can be from other parts, all right, which is fine. But mostly we can consider for water. It can be for steam, whatever that you can be given. Maybe it can be of a metal, talk of copper, talk of aluminum, talk of steel. All right. Then where there is a heat capacity, where we have got a heat value, because here, this one, it is Q is equal to mass times the heat value. This one, it uses the heat value, meaning to say, when you're talking about something like petrol, we talk about the heat value. When we talk about coal, we have got the heat value. So you must know where to use the formula, all right? So this one is best where there is a heat value for that particular object that you're working with. Is it coal? Or maybe you are working with petrol. It also has got this is what you can have here. Remember here, the heat values are given here for petrol and for coal. So whenever we are dealing with this, we can use that formula to calculate their heat. But where there is the specific heat capacity of water, steam, this, we can use that formula. Q is equal to mass times the specific heat capacity times the change in temperature, because we've got what? The specific heat capacity of these. All right. So that is the idea of our question there. That is the idea of our question. So, and also we're going to take the heat, because we need the heat value there for coal. We are dealing with coal, and the heat value for coal is given as what? 30 megajoules per what? Per kilogram. So that is 30 megajoules per kilogram. So also we have got the heat value for coal here, which is 30 megajoules per kilogram. All right, since we want to calculate this mass, we are simply going to divide by the heat value, isn't it? Yes, we can calculate the Q for this water, or we can just substitute as we understand this. All right, so this is the mass of what? Of coal. All right, times its heat value is equal to this side. We are talking about the mass of water times the specific heat capacity of water times the change in temperature. It simply means T2 minus T1. That's the change in temperature, T2 minus T1. So to find the mass of coal, simply going to divide by the heat value of what? Of coal. So this is the heat value of coal. So, you just calculate your Q aside for water. Then after that, you equate to this one, or you can just make it the subject here. So it means that the mass of coal is going to be given as what? So the mass of coal is going to be given as the mass of water, which is the mass of water is given as what? 500 kilograms. All right. So you're going to take 500 kilograms. times the specific heat capacity of what? Of water, which we are also given from our formula sheet here. We've got the specific heat capacity of water. I just want us to check here what we have. Sorry for that. Here, the specific heat capacity of water is 4,187. This is joules per kilogram degree Celsius. All right. So that is 4,187. 4,187 joules per kilogram degree Celsius. And the change in temperature we said is T2 minus T1. T2 we have it, which is 90 minus T1, which is 8. And we divide by what? The heat value of what? Of the coal, which is given as 30 megajoules per kilogram. So it's 30 times 10 to the exponent of 6. Mega means to the exponent of 6. So thus we can calculate the mass of coal direct from this equivalent, or you could have calculated Q for water separately. You get your answer. From that answer that you get, you now simplify this one. All right. So that's the idea of the question. So this is it. Let us have it. As we can see here, guys, let us just see. But you can see that our answer is going to be in megajoules there, because these are mega and this is called. Let us just use our calculator, no problem. So that's a fraction. 500 times 4,187 times 90 minus 8. 90 minus 8 over 30 times 10 to the exponent of 6. All right, so this here, my calculator is fixed to, if you see this fix here, as for me, I have fixed this calculator to 3 decimal place. So it's going to round off to 3 decimal place like this. All right, so it's going to be 5,7 to 3 decimal place. How do you do that? Shift, set up, you go to the fix on 6. All right, press 3 decimal place, so it gives you answer to 3 decimal place. So this is going to give us the mass of what? Of coal. All right, so that is 5,722 in kilograms. The mass is given in what? Kilograms. So that's 5,722 kilograms, like that. All right, so like I said, you could have calculated the heat of water, then we use that one for what? For the coal. You equate it, you calculate this here, then you equate to say the mass times heat value is that answer that you got, then you simply divide by what? The heat value of coal. It's one and the same thing, or you can make it the subject direct from the formula that you're given. All right, so that is how our questions are answered, guys. You answer the way that you understand much better. 7.4, a steel door with a height of 22.2 meters. So there is a steel door in that case, all right? So we want to understand about this door that we are given. Remember, this is a steel door. We are dealing with what? With steel in this case, all right? So it has got the height of 2.2 meters. Let's say this is our height, 2.2 meters, all right? So this one is now my bigger side, no problem. Then the width, which is 0.7 meters, all right, is manufactured at a temperature of 13 degrees Celsius. That is the initial temperature when being manufactured. It's at what? 13 degrees Celsius. So the question is that, all right, if the temperature of steel door increases to 37.6, which is our second temperature, T2, from this one, this is now our T2, which is at 36.7 degrees Celsius. Calculate the following. All right, 7.41, which is the first question, 7.41. We need the change in temperature. So the change in temperature is simply T2 minus T1. Final minus initial. Final temperature minus the initial temperature. That's it. So this one is just a straightforward question. That's T2 is equal to 36.7 minus T1, which is 13 degrees Celsius. So these are degrees Celsius. So our temperature is going to be given as 23.7 degrees Celsius, right? So it was just a matter of subtracting T2 minus T1, just like that. All right. Then they are saying on 7.42, the change in height, not the change of the width. Because remember, this is our height. Remember, this is our height, and this is the width. All right, we have got the height and what? And the width from this information that we are given. So the height is the one that we need, the change in height of the steel door in millimeters. Remember, we talked about the change in length on that condition that was asking us about conditions about the change in length. And I wrote this formula down that we saw from our formula sheet, that the change in length is equal to the original length times the linear coefficient of expansion times the change in temperature. So this change in length, but as we're talking about the height, so it follows that the change in height must be equal to the original height times the linear coefficient of expansion times the change in temperature, the one that we have. So in this case here, we are dealing with the height. So you must use the original height. If it was the width, the change in width, you must work with the original width that you are given. So since we are given here our answer to be in millimeters, all right, we're just gonna use meters, then we change our answer later on. So the original height is given as what? 2,2 times the linear coefficient of expansion of what? Of a steel. We are dealing with what? With steel. So we are going back to our information sheet. If we check here, for the linear coefficient of expansion of steel here, this is our steel. The linear coefficient of expansion is given as what? This is the value here. That's 0.00, like this one. Take note, per what? Per degree Celsius. So you're gonna take this answer for the linear coefficient of expansion of steel, which is 0.000012, like that. All right, times the change in temperature. Our temperature changed, and we calculated this change in temperature, which gave us 23,7. Yes, you can subtract again, it's fine, but you can just write your answer 23,7 in degrees Celsius. Since this is per degree Celsius, this must be in what? In degrees Celsius. So if you multiply properly, you're going to get something like 0.0006258 in meters. All right, let me just present this one to you so that we are together here. So also my calculator, I have to change this to the original mode. So it's shift. You have to go to the normal mode 8. All right, then press 2. It's now on the normal mode. If you check, the fix is no longer there. So this is it, 2,2 times 0.00012 like this times 23.7. So this is the decimal that we're getting, and it is in meters. And how do we convert to millimeters? Remember, 1 meter is equal to how many millimeters? 1,000 millimeters. So millimeters, this one, it's 1,000 from a milli. What about if we are given this, we say have to multiply by the 1,000 to go back to the millimeters. We must multiply by 1,000. So if you multiply this by 1,000, 1,000, right, like this. So this is going to give us 0.625, something like that, 25. So that's 0, sorry for that, 0, what? Okay, let's just save it here. 0.62568 in millimeters, like that. All right, so that was the idea of the question. Yes, you can round off to 3 decimal places if you want, but at least just try to write the first answer properly, then you can do your conversions part 626 in millimeters to 3 decimal places. That is, if you want to have your answer to 3, to 3 decimal places, but that is the instruction of the paper, so you have to leave your answer to 3 decimal places. All right, then they are saying here, okay, let us understand our question properly, the way it is given here. So they are saying the height, now you need to calculate the height of the steel door at a temperature of 36,7. What is the height at that temperature? At the final temperature, because that is our final temperature. So what is the height at this temperature? So they are simply asking you to calculate, in this case, the final height of the door at that temperature, which is the same as the final length. If you check from your formula sheet also, I want you to see this. You're also given these formulas. Also, the final length is given as the original length plus or minus the change in length. Plus or minus because it can be a decrease or it can be an increase. This one, we got a positive. So it's an increase in length because our change in length is a positive, all right? So meaning to say, in order for us to have the final height, in this case, the 7.43. All right. So the final height, just like the final length, it was supposed to be, the final length is equal to original length plus or minus the change in what? The change in length. So here we're talking about the final height. So the final height is going to be equal to the original height plus or minus the change in height. But in this case, we got a positive. So it's just going to be the positive, the change in what? In height. So what is our original height? Depending with our answer, are we going to write it in meters or we are going to have it in millimeters? If we are to have it in millimeters, it means, it means we have to convert this one to millimeters. Remember, we said 1 meter is equal to 1,000 millimeters. So we simply have to multiply. We're talking about the original height, not the width. What is affected is the height. What is going to be the, not the width, what is going to be the height at this temperature? The height, not the width. So you are focusing with the height there. All right? So meaning to say, we can change this to millimeters by multiplying by 10, by multiplying by 1,000 here, because 1 is 1,000. What about 2,2? We multiply by 1,000 to convert to millimeters. So meaning to say the original height, 2,2 times 1,000 plus the change in that height. Remember, the change in height we calculated already in millimeters. We got 0,626 in what? In millimeters. So if you are to combine this, that was going to give you 2,200,626 in millimeters, all right? Of which you can convert back to meters, all right? It's up to you, but you can also leave it like it as it is. If you were to if you were to use in meters, you are going to use 2,2 plus this change in what? In height. You must use the original one that we must use. I mean, the one that we got in meters. Remember, we got the value in meters here, this value. So you're going to write that value as it is up to the end. That is what you're going to have. All right. You're going to check, need this one. So you're going to write this value as it is. Okay, which one do I want, guys? I said I need this marker here. All right. So this is what I'm trying to say. In meters, you're going to have 2,2 meters plus that value that we had in meters, which was 0,0006, 02, and so on, which is 26, something like that. We add, you're going to have 2,00, 2,2, something like that, 2,2, 00626 in meters, which you can just round off to 3 decimal places. It's going to be 201 in what? In meters. So that is how we could have calculated this in also in meters, because we are not given the unit of measurement to take or to use. So it was a matter of your choice or to answer this one. So these are the typical questions on heat. This is our question on heat, November 2023 exam. So let us just try to also do as much questions as we can. Try to work with more question papers. If there is a question paper that is having a challenge, then we can try to send it to my WhatsApp so that we can do that question together on this platform, so that you can be able to revise towards your exams that are ahead of time. But for now, that's it till we meet again.